Good morning, everyone. This is my overview for Tropical Cyclone Bianca that's in the southern Indian Ocean right now. Let's get straight into it. We're going to begin by going over the forecast cones that we have from the official agencies. Then we'll go over to the current state of the system and the current structure, what we can currently see happening with Bianca, the track forecast, and then we'll look at the intensity forecast and the environmental conditions. Right, so let's go over and go through what we currently have forecast by the official agencies. So the Bureau of Meteorology, as we can see here, the official tropical cyclone warning centre for the area that Bianca's in, it currently has analysed as a Category 2 on the Australian scale. That's around Category 1 on the Saffir-Simpson hurricane wind scale that the Americans like to use. And they have it forecast to intensify to a severe tropical cyclone on their scale, a Category 3, later today, with the peak lasting until tomorrow, where it should begin its weakening process. Fairly quick weakening process, it degenerates into a post-tropical cyclone. Overall, it's not expected to last too long from now, with a short peak fairly imminent now, soon before it ends up dying off. And what do they have in their technical discussion? I want to look through their technical discussion, see what they think, and then we're going to do some more in-depth analysis into the models and the current environmental conditions. We'll look through the current state of the system, we'll take a look at everything ourselves, but we'll see what the Bureau has currently done and what they've currently written in their last advisory. So they've got a developing eye that they've noted, and their Dvorak analysis is at a 4.0. Yeah, based on DT most likely, but they've also got the PT at 4.0. That's the pattern T number, analysing through comparisons to various diagrams and extrapolation. And then the DT is for objective measurements, like the curved band being analysed at 1.1. And then they've also got the objective estimates, ADT, the AI DT, dprint, SATCOM, and again, eye developing, and they've set it at 55 knots. They use 10-minute winds, 10-minute sustained winds for their estimates, and therefore the 1-minute sustained winds that you would normally see by the Joint Typhoon Warning Centre or the National Hurricane Centre, they will be slightly higher because the 1-minute sustained winds are likely to have higher maximums. If you're using the American standard, aka the 1-minute averaged winds, we're probably going to see this being around 65 knots. And that is a Category 1 system, and with it developing an eye and the DT being a 4.0, that is not very surprising. They've analysed the vertical wind shear as low, at 10 knots or less, with strong upper level divergence. That'll be outflow, probably poleward, given that it's supposed to be heading southwards, probably being pulled by a deep layer trough. And dry ice around the system, not significantly impacting the core, likely because the vertical wind shear is not very heavy to affect the dry air mass into the core. And sea surface temperatures are adequate at 27 degrees. They expect it to remain favourable, the environment, until Tuesday afternoon, where it's supposed to peak. And they expect it to intensify into a severe tropical cyclone, but then obviously cooler waters, increasing shear from the approaching trough, and subsequent dry air intrusion will be prevalent. And there's high confidence in the track. Let's compare now to the Joint Typhoon Warning Centre cone. They have it estimated at 75 knots, so the Bureau might be underestimating. This is on the latest 9Z. Yeah, 9Z. This is on the latest 9Z advisory that Joint Typhoon Warning Centre's issued. They got it at 75 knots currently, with a peak expected in 12 hours at 85 knots. That is a low-end Category 2 before it heads that way and begins to weaken. Initially, slowly, but then it does become a bit more rapid later on, especially as we go into the 26th and it heads even more south. The the latitude there, 25 degrees south. So, oh, what's happened here? Oh, there we go. Right. Yeah. So, 25 degrees south. It heads south. The environmental conditions will become definitely more unfavourable after the peak happens later today. And what's their reasoning? What have they got? Will likely be similar to the Bureau's. Ragged convective structure, disjointed, central it's overcast, but it is stated to be becoming more organised, with strong polar outflow channel, vertical stagnant vortex, radio outflows observed, and microwave eye present in microwave imagery, but I'm not sure why they referred to 12-hour-old microwave imagery. That's a bit weird. But indication of further improvement since the issuance of this warning. So, okay, all right. But it's not very recent. That's because this is an older. So I'm wondering why they've mentioned. So I was a bit confused initially. There we go. Right, this is the latest one. Because before I began the video, it ended up. I didn't even realize it ended up loading up the previous advisory. So, and they issued 12-hour ones. So even more outdated. Now this is where we should probably see some more accurate description. Low level cloud, low level cloud, banding, wrapping into a cloud-filled ragged eye. There we go. We got eye mentioned initially. Now developed over the last 6 hours. Cirrus filaments expand from the center of the system, indicating radial outflow. Strongest outflow region is the polar outflow channel feeds into the subtropical jet. And then at 75 knots based on this data. 5.0, the Dvorak technique analysis, 5.0, 5.0. This is the BOM, by the way, APRF. That actually got the lowest the subjective Dvorak analysis value compared to the others. This is the JTWC. This is the satellite analysis branch from the NOA. And then this is the Indian Meteorological Department, which also issues the Dvorak analysis, and they've got a 5.0 as well. And overall, we've got 90 knots, 90 knots, 77 knots, and 65. And then the objective estimates are also running on the lower side. There's a fairly big range, and I think the JTWC just went smack bam in the middle, which is fair with the current structure. I'll go into it and I'll look in a second. I'll show you guys. But yeah, what they've currently got, 290 knot estimates. What most important thing is that instantaneous Dvorak fixes shouldn't be taken at face value unless there's some decent agreement between multiple agencies. Don't take one or two instantaneous Dvorak technique analyses at face value. What the SAB actually likes to do in its own fixes is they like to take typically the 3. It might even be 6. They might even be willing to take the 6-hour average DT data T number when they apply the Dvorak technique. So then their instantaneous value is realistic for when the fix is issued. So keep that in mind. And then obviously we look at the forecast or assessment of the current environment. Vertical wind shear, very even lower than what the Bureau actually ended up stating, 0 to 5 knots. 26, 27, so there's good agreement on analysis of the sea surface temperatures. That's a little bit more objective, so I see that. Strong polar outflow, as mentioned above in the discussion. And then obviously in terms of track, they expect it to curve southwards on the periphery of a subtropical ridge on the western periphery, and that'll be for the remainder of the forecast period, which goes up to the 26th. Though the Bureau has it extended for a bit longer than that, into the 27th. This is probably when it starts moving within the low-level flow, as the vortex becomes shallower and the low-level flow becomes the main steering mechanism. And obviously this is just, because there's actually, I'm going to go on in a second, they've obviously got 12 hours of environmental conditions, so short peak, imminent peak, before it causes subtropical transition. The environment. That's their definition of subtropical transition. What I need people to know is that subtropical transition and just subtropical nature really is still a very it can include a very wide spectrum of systems. There's no fixed definition. We'll follow the National Hurricane Center definition for a more, I guess, for a more consistent variant, really. If that's how we want to interpret subtropical cyclones, we'll follow the National Hurricane Center, I guess, their standard that most people might be more used to. It's also because most of their subtropical cyclones that they designate, the JTWC, they're typically remnant lows, and they make sense. When I mean remnant lows, I mean National Hurricane Center would designate these type of systems as remnant lows or post-tropical cyclones that are not frontal. There's also some frontal systems that they ended up having as subtropical cyclones, but I don't want to derail too quickly, or too much here, really. The point is, they might be saying about subtropical transition, I want it to be understood that it's just degenerating into a post-tropical cyclone, as it loses its convection heading into cooler waters. They also state that deterministic model guidance is in good agreement in the near term, and I'll go into that in a second. But then, what I'll say as well is that closer to the end of the forecast period, and around after 24 hours near post-peak, there is increasing variance, increasing track spread within the ensemble, and the various ensembles and the model guidance that we have, and especially as they say beyond the forecast period, they have, there's quite a bit of bifurcation, as they state here. And they say that the difference is likely associated with a stronger interpretation of how significant the dry air entrainment and vertical wind shear would affect the circulation. Alright, I'm going to give my verdict, and I'm going to go through what we have right now, and go over the forecast models and see what they have, and then have my own interpretation to see what's happening. We'll also look at model trends and evaluate what the current situation is. So, this is the system right now. Let's get a more updated image, and let's actually run the loop to begin with. So, this is going into afternoon, 23rd. And we see gradual organisation. That core now began to build fairly quickly, and brief eye disappearance there, but before a new one emerges, there's a clear bias, or should I say, there's a clear lopsiding nature, really, of the convective canopy to the west side. As we can see there, most of the convection is there, and eye is rather ragged, and the convection is, from what we can see, there wasn't much convection on the west side, east side, sorry. Let me move this to begin with, because last video with Ray, we actually had a bit of a problem with it keeps moving. We had a bit of a problem with this, and how it kind of blocked the color bar that we had there. I couldn't really analyze the exact values, and now I need to actually get to this menu, this interface. So, from what we can see here, currently, we can see here that there is a lack of convective structure. The central dense overcast is very lopsided to this side, and there is very little to solidify on that side. We'll look at microwave imagery in a second just to see what under the hood looks like, but it should be somewhat similar. And you know, there's an eye that is evident, but convection is nowhere near as strong on this side compared to the west. And why is that? That could be a sign of dry air trying to get in. Though I think we're also seeing progression of a vortical hot tower making its way around, and that could soon solidify that side. And that will be good for near-term prospects as we near the peak intensity. But overall, it's doing fairly well, as we've seen. I'll run the loop back again. And evidently, we can see that nice central dense overcast formation, that eye structure became very clear. Now it's back again with a more defined, clear wrapping vortical hot tower now making its way. It's definitely more organised, the way that it's producing convective bursts. It was obviously in its formative stage earlier on. Now it's definitely in the process of maturing with a more, I guess, clear, organized vertical hot tower wrapping. We're definitely getting closer to category 2 as I speak right now. What would I estimate this system at? Well, at 6E, the JTWC estimated it at 75 knots. Let's take a look at the evolution in a second when it gets to that time. My loops are unnecessarily long. I apologise for that. So 6E, nice high structure. Yeah, 6E, 70. I can see 75 knots. I'd probably go 70 though. We're probably nearing about 75, 80 right now. So JTWC is actually pretty spot on with its estimate really that I had. And yeah, as I said, we're nearing category 2, and I should probably be looking at the Dvorak technique scale, the BD scale. And we'll be able to see it. Yeah, fairly. This should probably get a 4.5 or a 4.5 to a 5.0. Or at least earlier on it was. The east side again, as I said, it degraded. It's not looking too good. But this should get a decent Dvorak technique output, really. Nice off-white colour eye. We'll get the value there. Yeah, so we got a value of 4.14. I think that might just be around that place. Well, I don't want to look too deeply into the eye temperature, though we do know for a fact that an eye is becoming more evident. An eye has generally warmed. Yeah, it is warm medium grey, which is the temperature's higher than 9 degrees positive. So the eye evidently clearing, though it definitely does have work to do on its central dense overcast, particularly on the eastern side. Now further observing the central dense overcast and its core evolution. This is not the cyclone that we're supposed to be looking at, but let's take a look at the microwave imagery just to further look at that core structure, and rather than just the convective structure, we'll see what's happening underneath. And this is the latest image at 717Z, and again, some of these images are going to be quite old. We've just looked at the very recent kind of evolution. That eye structure, that convective structure that's just appeared, it isn't anything particularly old. It's actually quite new. If we look here, we'll be able to see that it's 6C that it eventually materializes. It's after 6C that kind of structure becomes very evident. So it's actually quite new, very recent. Also, we can't really observe much from this pass. It's very difficult. We can see some loose core structure, but the resolution of this microwave image is it's not particularly great. So it's not anything of significant use. See what other data we have. This is 647Z on, and let's take a look at the archive here. We'll begin with this imagery. 647Z, this was when AMSR2 passed, so that is one of our better quality imagery that we have. And we can see very nice, it was strongest on the southern quadrants initially, but still quite a well-defined large eye compared to the ring thickness that we have here. But that there is a ring that is attempting to solidify there. That's a decent structure in the making, or at least what appeared to be. Now, imagery coming in at this time would probably show the core structure being a bit lopsided on this side, as we saw with the convection, and there would probably be a little gap on the eastern side. And so as for later, while we got that now, we've also looked through that type of imagery. We'll look through this one. This is the latest low level 36.5 GHZ imagery that we have here, and again solid on the low level southern side, southern quadrants, but then yeah, evident ring that is present on that side as well, though not as strong, but still one is there very clearly. That's a good core structure, decently not bad. And then that's what it was when it passed at 647Z. Now it might look a bit different, but overall, I don't think there should be any like significant changes overall. At least none that are negative entirely. I mean, that's still quite a nice eye in the making, and that central dense overcast isn't completely bad. It's just missing a few pixels on that eastern side. It would need to wrap there. It's not entirely. Essentially, whatever bias was on the northern side, with it being weak there, is probably now shifted to the eastern side, and the general area where the core is weak is probably on that side as well, and it's probably decreased. So, I would say this is intensifying, and it's looking fairly good. Looking at the track next, this is what the GFS 0C had. We are going to get new runs soon, but for now we'll look at what we have. This is a 0Z run, as I said, good certainty to 24 hours. This is generally just after peak, so as we can see with the colours there, the minimum central pressure above 980, though I think the GFS might be a little too weak. Will not take the values there at face value. And then after 24 hours we see split increasing. There's that's decent spread there. And the forecast period generally goes to hour 48, at least for the JTWC. That's around there. After that we see very big spread. I'm not exactly sure where most of these values extend to. 72 hours. There's one 72-hour point there, and then there's another over there. So that's decent spread there. And generally it becomes all messy onwards. Other than that, like onward from there, as we head westwards in the low-level flow. And we'll take a look at the maps here. And we'll look at the 500 millibar height plots that we have here, and we'll see in a bit of a better view rather than looking at the ensemble view. To be fair, although we do like looking at the ensemble and looking at all the various possibilities, we do definitely want to look at the deterministic models for looking at plots like these, seeing what the high resolution one solid deterministic solution has. We'll begin with the GFS. We'll look through all the various models. We'll also look through the ensemble plots and the ensemble's the ensemble member plots on just to see physically on a map how these ensemble members are plotted. So let's begin with the with this one here. This is where it is. Sorry, this is way too far forward. Stick 12Z, we're closer to 12Z now. It's currently 937Z at the time of recording this. And we see this is where the system is. It's quite compact, and I'm sorry I don't have a closer up view. Tropical Tidbits, great website by the way. Definitely go check it out. Don't actually have a plot that zooms in closer to this area. I don't even think the Australia plot boundaries actually extend to where Bianca is. So yeah, I can't really use it. But we'll use what we have. Currently steered. I need to press my marker. So obviously, like the forecast discussions that I read through said and noted, ridge in here, very evident ridge in here, that will provide that southerly southwesterly flow that take Bianca on the generally southerly path as it rounds and curves southwards around that ridge. It's also being, I presume it's also being influenced by that trough that passed. Obviously there's no blocking to the south to take it in any way that way, yet at least, not yet. There's no way it can go westwards at the moment, no easterly flow. It's generally southerly flow that is being influenced by that ridge that's to the east, sorry, and there is that upper trough, that deep layer trough that's also taking it. It's also the deep layer trough that will be supporting it in its intensification. I'll go through that in a second. And yeah, it's also what's steering it. For now, at least. Now let's get rid of all that. This is now 36 hours, so we're looking at 12Z Tuesday now. This is where it begins to weaken. We see that deep layer ridging still very evident, still takes it south, and the remains of what that trough pattern remains, and the low does continue to head towards that until it becomes very shallow. That's why you can't see it here. We'll look at the, this is where it becomes influenced by the low level steering flow. So this is where we need to take a look at the 850 millibar vorticity plot ideally. Then we'll have a better idea here. So we have that region over there to its east. This is where, so we're looking at forecast hour 60, 12Z Wednesday, and this is where it does not catch up with the trough, and it is too weak now at this point to really get influenced by any significant mid-level steering influences. So we're looking at this low-level ridge now. That's going to be pumping nice southerly flow. Sorry, this is me going back, by the way. You guys should probably see the timestamps above. And then yeah, we got that stalling there now as it's too weak. There's no influence, no significant influence by that trough over there. And with this ridging in place, it's going to be pumping nice southerly flow that take it to the west. To save my life, I could not draw good arrows. I'm sorry about that. But yeah, it just gets taken that way, and then because the environmental conditions are no good, it just dissipates within the low-level flow. And that's the kind of steering influences that we have for Bianca. If we look at the various ensembles, we'll begin with the GFS because that's where we are at the moment. If we look at all the ensemble members, we can very evidently see that there is a compact area of members where it's going down here, and then that spread becomes very, I drew it too far south, and then that spread really becomes evident. Like, well, let's compare spreads here. This is 12Z or 18Z. We'll look at 18Z bear 12 hours from now. Very compact, almost like nothing's changed, almost like they're all the same really. Very compact area of members. And then let's look at 72 hours from now. Much increased spread. Now why is this? My theory is this has probably got something to do with peak intensity and its ability to weaken faster or slower. When you keep your higher intensity for longer, the influence by that deep layer trough that passes there will be stronger for a bit of time. It might be a bit more influential for a bit longer, and therefore it might be taken a bit more southeast. We can see that with some of the contours. If we look at density contour here, slightly brighter contours there. That's probably because the system is still trying to die off from its higher peak intensity, and it got taken by the trough a bit more. And compared to some of the, we can see it, yeah, that there's a clear density bias there. You can see it a bit earlier before it completely dissipates, and they all get on the same level because the environment is that hostile. And then if we look here on the northern side, northern tip, that's typically where your weaker systems are, and them dying too quick, them dying quickly, shows that obviously they are decoupling quicker, they are weaker, they've got a shallower core much quicker, and therefore they are influenced by the low-level ridging flow that becomes quickly established. They get more influenced by that low-level flow more quickly, much faster than ensemble members to the south, and therefore they get taken, they get pushed further north, they get kept further north, and then they make their westwards move much more quickly. And then obviously this is just one model, best to obviously as a forecaster look at the various guidance that you have in place. And let's look at the EPS solution. It doesn't resolve the lows for much longer, but it does resolve them for as long as we need to look at them. Again, very similar situation here. though not as clear. This is hour 54, so uh, this is what we have for the EPS, and they have stronger members to the south because of the reasoning that I gave just a minute ago. Fair density. They're actually quite dense in the short term initially. This is hour 42, but then that spread becomes much more evident as that low-level region builds in and the system ends up dying off. I also forgot to look at the ECMWF deterministic, which might be a good idea. And yeah, obviously similar steering influences. I mean, that's not surprising. In the near term, models are going to be likely in agreement. This is a pretty straightforward setup, trough ridging setup. You see this in most places around the world, probably 100 times in North Atlantic. Like this, this is nothing out of the ordinary, fairly expected. And yeah, that's what we have. To look at that low-level evolution, yeah, good agreement between the GFS and the European suite on the track evolution of the system. Now, let's look at model trends. Let's see, has it been fairly consistent? Now, we'll look at peak intensity. This is actually 6E. The 6E model run's actually running now, but we'll stick with the 0C to begin with because I want to be consistent across looking at all of the guidance across the whole of this video. So let's look at peak intensity, which will be 80Z-ish, and we'll take a look if there's any significant track differences. Has it been consistent through time? For the most part, very consistent. I've gone back now 8 runs or so. This is a run for 0C February 22nd, and we can see, going back forward now, barely any difference. It's been well forecast, the kind of position that it's in right now, so that's fairly good. And then let's look at forward in time when it's like kind of dying off, where there's a bit of a higher uncertainty at this time. Again, fairly consistent, but there's been some shifts, a bit like ideas draw. There's been some shifts kind of around this area where I've marked, and particularly here. There were some systems, some of the model runs indicated Bianca going down here. That's probably because of the fluctuation between the strengths of the system initially, and that resulted a bit of a longer influence by the upper trough that ended up passing there. And then I assume there's going to be quite the same kind of straightforward consistency with the ECMWF solutions. I'm not going to go too deep into that. We have to look at the intensity and the environment now for Bianca. Now, with Bianca and its strength, as again, we've looked here, right? We've looked here at the ensemble. We'll begin with the ensemble since we've already got the plot here. I don't want to go forward without making the most out of the plots that I've already got further left along my tabs. And we'll begin here by saying that this is probably vastly underestimated. We've initialized at 993 at 0C. I'm pretty sure that was the pressure on the ATCF on the best track. I'm not sure, but I think what we have here with relation to high 980s in terms of pressure, I think we're going to get a bit lower than that. I feel like at this time it's overperforming slightly in terms of intensity, but we'll look a bit deeper into that in a second. So this is the upper level environment. This is what I like to begin with when analysing the environment. And what can I find initially? Let's look at 12Z. Broad, oh for God's sake. Broad upper level anticyclonic flow that's present over Western Australia, and that is generally fairly expansive over around there, and Bianca at 12Z is embedded within that broad upper level anticyclonic flow, and then because it's displaced from the centre, it does see some northerly flow, should I say west-north-westerly flow, uh, east-north, east-northeasterly flow. Sorry, I keep getting the two mixed up. I don't know why. We've got the east-northeasterly flow coming in because it's displaced from the centre of the upper level anticyclone, but because it is aligned with the incoming trough, or aligned in the sense of it approaching, it's in a good position. It does benefit with a good jet interaction. Its poleward outflow is strengthened by the subtropical jet that's passing through, and its outflow vents into that flow. So that's very good for near-term intensification prospects. We've already seen that, and it's always been like that actually for quite a while. This isn't anything new, although that outflow is notably stronger now than what it was before. Because it's nearing closer to that jet, and that outflow is now getting enhanced. But previously, that upper level outflow that vented into the jet previously, it has existed. Because obviously it's positioned around the upper level anticyclone. It's always had its outflow forced down further south, rounding that upper level high that we've got Bianca embedded slightly in. And it will continue going that way until it gets a bit more within the range of the upper trough, within its influence. Obviously, it's heading further south at this time still, and obviously that upper trough doesn't actually progress so much. Maybe the core base of the upper mid. Sorry, maybe the core base of the deep layer trough does pass. Obviously, we see the jet streak move a bit that way. That does happen. But there's a bit of a chunk of the upper trough that does split off. And that upper trough, that kind of sector, that kind of piece of the upper trough, that comes off. Because the system heads far enough south, and that piece ends up staying where it is. Very intense northwesterly flow comes over the system, and that's what makes the system shallow. We got very intense deep layer shear that comes at this point. How do I know this? Well, let's look at the soundings that we have here. That was at around 54. And we can look 54. Very intense deep layer shear. That's across all levels, from upper to mid levels. Upper to low levels. 35 knots. Very intense flow. And we can also see here very northerly flow coming from there, and that's across all levels. Though there's also a bit of a discrepancy between the direction of the winds and the flow, but generally we see very intense flow coming in 20 knots, mid-levels particularly as well, so that's going to be harmful, and because it's not moving anywhere significantly, ignore the steering, because at this time, this is the deep layer steering, by the way, so this is not following the low-level steering. You can see low-level winds there, easterly, so it does follow a more westerly direction. It goes west, and that's because it's a shallow system, as I've gone through. But yeah, we've got that deep layer shear coming in, opposing its direction. Ignore this. That's not to be looked at. And yeah, it increases even more. Well, look here. It increases even more because it decides to go west towards the base of the upper trough that we have here trying to split off. And the European solution also. And if we look here as well on the European solution that we have here, should be fairly the same as well. We look here, coming off peak intensity, and trying to obviously interact with that trough, because that trough is a little too fast and it's a bit too ahead of the system. It obviously doesn't catch up with it, and it just gets stuck in that north-westerly flow, and it ends up dying. Now, We see that that's the upper level environment. Obviously, we need to look a bit deeper. As I've said, let's look at the soundings in a bit more depth here. Not just at this particular point where it does get into the jet, but let's look at the peak intensity and how it's going to get to it. So, what is the environment looking like right now? And what's it going to be like en route to it getting to its peak intensity? Let's take a look at it. So, this is 6Z, this is a couple of hours ago, and then this is 12Z where we're approaching. As we can see, first sight, good shear values, good shear values for the most part. Deep layer shear, 2 knots, so I guess that's good. And if we look at the hodograph here, although there is some low level flow that appears more easterly in the far low levels, generally at 850 millibars, and for most of the profile, we stick to the motion vector of the storm. It's very aligned, and that's going to be good. Explains why we got a deep shear at 2 knots and max shear only at 9 knots, and that's in the far upper levels. That's here. This is not too important, not exactly too relevant, and it's not going to be that detrimental. So obviously that's not really that much of interest, and obviously we're looking mostly at our mid levels, the more detrimental type of shear, and we can see most of the flow quite fairly aligned. We can see the steering at 6 knots going in the same direction of the hodograph. We can see the flow is quite aligned, and the upper level shear environment is also quite favourable. If we look at the relative humidity, deep layer relative humidity, 73%, that's okay. There is quite a lot of dry air within the facility, but again, with the shear vector quite nicely aligned with the motion vector of the storm, none of that shear, no shear should really exist for significant importation of the dry air mass into the core. And although, as we've seen on the satellite imagery, it was trying to get in. Or look here, it was trying to get in that vortical hot tower. Now, obviously, we've just seen it right now in those last final frames. There was a vortical hot tower that was wrapping and was able to secure that kind of area, and was therefore probably able to close off that core, and it's probably going to allow for some more intensification, which is very ideal. Now later on, when it begins to degrade, how does the environment worsen? Well, let's take a look here. 24 hours, 30. 30 is a good place. Okay, so when it does move at 10 knots, to begin with, it does move 10 knots due south. We can see a lot of that flow easterly still, and the low level flow has strengthened actually. Most of the mid level flow actually begins to become a bit not aligned, and this is not just based on wind speed, because it's obviously 15 knots now, but it's also heading in a bit of a different direction. It's headed more southwest, while the movement of the storm is now due southerly, due south. Although most of the upper level flow is a bit aligned, obviously again, we've looked through, that's less important. We're focusing on the 850 to 500 millibar flow, and that's now heading in a bit of a different direction for the most part, compared to the storm vector. And this environment only gets worse, particularly because it now moves as slightly south-southeasterly, the storm does, and the mid-level flow remains at 15 knots, and low-level flow as well, 10-15 knots, and it's not aligned. It's heading that way, easterly, southwestwards, heading from northeast, while the storm is heading south-southeast. So this is what's the flow that the storm's embedded in? Northwest. And we can see a bit better with the within the sounding profile that we have here. If the storm is moving that way, that's going to be some shear that's impinging on the system. And further down the line, this is where the mid-level shear becomes a bit more detrimental as well. 54, early February 26th. This is when it should begin to degenerate into a post-tropical cyclone again. This flow is, although not anything like really strong, but it's around there. We've got 20 knots of mid-level flow that's due southerly here. And then we've got southwesterly flow, sorry, northeasterly flow that's heading southwest. That's low-level, mid-level flow. That's not aligned with the southeastward motion vector of the storm. And as I said, the profile, it doesn't show so strong winds. It doesn't show on the profile down along the mid-levels and the low-levels. The winds aren't exact. Hello, sorry, I don't know why my video cut off there, but we're back now. Let's get back to analysing. So we got hour 54, February 26th, 6E. Now this is where the shear starts getting a bit more detrimental here. We got 20 knots mid-level flow, so that's 15 knots mid-level flow there. And that's northerly flow heading southwards, and then we got some eastward flow as well, westward flow heading from easterly there, and the system vector is southeastwards. So that's northwesterly vector, and then we have, from what we can see here, there's not so much alignment. But as I said, I don't know if I've said, but there is not much difference. Well, the main difference, the main kind of discrepancy here is flow direction. Right, we can see some easterly flow there, westerly flow there, northerly flow there. It's kind of just like it's a bit of a mess here, but the flow's not all that strong. And you know, in this, what I was saying when I didn't realise that the video got cut off, is that they in a bit of a more moist environment, this could have probably been a more acceptable holograph to some extent, and because although there is some, obviously, as I said, there's some differences, there's some misalignment with the kind of direction the flow's going. The strength's not all that bad. What makes this all worse and what makes this heavily unfavourable is the fact that the relative humidity, deep layer relative humidity in the area is only 60% now with all that dry air nearby, with the vortex clearly sheared there. And now all that dry air is now coming in because the shear is allowing it to. We see vector, storm vector, 10 knots only, and then the kind of northerly mid-level flow is 15 knots. That dry air is going to be able to get in. Also, with some of the flow being quite easterly, particularly in the lower mid-levels, that dry air is easily going to be able to curve in and get into the system core and make some pretty nice degradation. And obviously, it should be no surprise that the ECMWF does agree to some extent. We'll take a look at that now. Although it's taken quite a bit of a long time now to load in, so yeah, it took a while, but it got there. And yeah, I mean, overall, even on the ECMWF, it does degrade. It does degrade. We can see some degradation here. We're gonna obviously have to wait for these plots to load in, but they will load in a minute. Yeah, there we go. Just gotta be patient for a bit. We can see hour 30, quick degradation. Now, why do we kind of see this, and why does most of the relative humidity go that way? AKA the convection where it would be, why does it go that way? Why does it go southeastwards? Well, we can see here that that's generally because we have nice easterly, south, or should I say northeasterly flow, southerly flow. That does, again, as we've seen, it might be a bit more aligned with the motion vector of the storm compared to the GFS over here, but still there is misalignment with the direction of the flow here. We can see very mixed kind of direction. It's not particularly all aligned, and therefore we have so much dry air in the facility that gets imported. Let's zoom in actually. We've got this dry air that gets imported within this flow because there's northeasterly flow there. That southerly flow, dry air, there's a lot of dry air to import, and it does get imported. This is a window now. And once again, this is what I said. If there was a moist environment there, we wouldn't have had such a problem with the misalignment of the flow. Sure, there would have been some shear, and there is, definitely is some shear. I'm obviously not saying that there isn't. But it's that what makes this incredibly detrimental now for the system is because there is dry air to import in the vicinity, and then that's essentially what kills it off. And the models do agree with that. And then what else? What else should I look at? I mean, let's take a look. I need to go off this. Let's look at the sea surface temperatures of the system. Obviously, why I don't go onto the sea surface temperatures initially too much is because um, there is more relevance, or should I say more importance even, to how the upper levels are structured, how the flow through height is structured, what the environment is above the surface, because convection and convective structure really does matter in a vortex like a tropical cyclone that needs to be aligned for development. But the sea surface temperatures absolutely will be a factor, especially at this latitude. Why cyclonic weather is not taking so long is, I don't know why. But I'll go over sea surface temperatures at this latitude where it's quite a dry environment, and we are getting to latitude 20 degrees south. In the southern hemisphere, this is kind of where the boundary is between less favourable and more favourable, with the 27-degree isotherm not too far off. We've actually seen in the forecast discussions that the environment includes 26-27 degree sea surface temperatures. That's relatively borderline. I mean, that can decently sustain the system, really, if other environmental conditions like ambient moisture and the upper level flow, that's all decent, then 27-degree waters aren't too bad. We've seen category 5 systems in those waters. Some, not too many. It's not common, but it does happen. And what needs to be taken into account is that in this kind of marginal environment, sea surface temperatures will play a role, especially with dry air around the place. If there are dry air entering decent amount of warm waters, what should I say, decent temperatures, a decent sea surface temperature area, there's going to be more likely potential for moisture to develop, rather than in cooler waters where latent heat isn't really around that much. So, where we do have somewhat marginal sea surface temperatures here, as we said, we've looked through the environmental conditions to sustain that moisture bubble that it has are fairly good, and they should be alright. But although I have stated the kind of temperatures that we will have, unfortunately, I cannot show them to you because cyclonic weather is not taking thing that I'm going to look into, where we have a broader view, a global view of the relative humidity that we have here, and we can see after peak intensity that shear does allow for importation of that dry air, and we can see quick weakening there, where that moisture, deep layer moisture, does end up getting displaced and taken by the upper trough, or whatever's left after it passes. And then yeah, it cycles that dry environment, and it obviously dissipates. There's fairly good agreement on the kind of evolution that we have from multiple systems, and that's kind of what we can expect here. Now, what do I expect for the system? Well, based on the current environment, we are seeing quite a decent strengthening trend. I cannot see the floater anymore. Unfortunately, we can probably load it up on tropical tidbits. So we'll take a look here. Yeah, we can see here, very nice developing central dense overcast with nice eye becoming evident. It does need to fix that eastern central dense overcast area, but then I think it can definitely do that within the next few hours. We are seeing obvious structural improvements, so that's a good sign. Estimating it at around 75-80 knots right now. It does have quite a bit of a short window, but it does have some window of some sort within the next 12-18 hours to get its things together and to be able to strengthen to an intensity of around maybe 90 knots or so. And what does the JTWC expect again? 85 knots. Yeah, that's not too far off from what I expect. What hindrances are there? Well, we'll see. If the environment proves to be a little bit more uh, a bit less conducive than what's expected, we could have a bit of a problem with regards to the peak intensity being, I guess, stopping a bit shorter, or it might essentially have a bit of a quicker weakening rate, so it doesn't last as long. But with regards to peak intensity, I don't know, we'll see. We could have, depending on whether the shear increases a bit more quickly than or not, we could have more regular dry air intrusions, faster dry air intrusions. We'll see if that peak is shortened, limited, or stopped a bit earlier. We'll see how the progression occurs through the day. And yeah, that's all from me, really. Don't need to look at that anymore. Yeah, we'll definitely take a look at the officials. Definitely keep looking at the officials. Keep taking a look at the official information that's issued, and definitely keep up to date with the latest information. Keep watching if you're an avid enthusiast, but this shouldn't hit any land. So for real interest, really for real purposes of keeping people safe, there's no need to really worry about this. Heading out to sea, thank God, a nice sight potentially for enthusiasts to look at. And I hope you guys enjoyed this informative video of looking at Bianca. A bit long, but I've had a lot to say about this. Thanks for watching, guys. Hope you guys enjoyed, and yeah, I'll see you guys in the next one.